Let's continue where we left off. So for the second interval, I'm going to replace x with 1 into the second derivative. Equals 12 times 1 square minus 24 times 1, which is negative 12. So this is negative. That's not 0. This interval is negative, so it's concave downward. Last interval, replace x with 3. So you get a 12 times 3 square minus 24 times 3. So it's 12 times 9 minus 72. 108 minus 72 is 36. Again, it's positive. That tells us it's concave upward. So now if you look at it, concavity changes at x equals 0 and at x equals to 2. Going from upward to downward, downward to upward. So concavity changes at x equals 0 and x equals 2. So the point of inflection occurred at x equals 0, x equals 2. So let's take a look at a graph really quick, and you can take a look at detailed solutions from the PowerPoint. So from negative infinity to 0, it's concaving upward. From 0 to 2, it's concaving downward. So the point of inflection occurs here. Second point of inflection occurs at x equals 2. Here this is concaving downward, concaving upward. Then the point of inflection occurs here as well. Okay, so that actually matches with our analysis. Then the very last topic in this particular section is the second derivative test. It's the test for extrema. Second derivative test, let f be a function such that f prime of c equals 0, meaning critical numbers. You're looking at the critical numbers. Then you're going to test the critical numbers in the second derivative. And the second derivative of f exists on the open interval containing c, containing the critical numbers. So if the f double prime of the critical number is greater than 0, then we have relative minimum at c comma f of c. If f double prime of c is less than 0, then we have relative maximum at c comma f of c. If f double prime of c equals 0, then the test fails. I'm going to go back to the first derivative to figure out whether it's a relative maximum, relative minimum, or neither. Okay, so let's take a look at the example using the second derivative test. Find the relative extrema for f of x equals negative 3 x to the 5 plus 5x cubed. So first of all, in order to find the relative extrema using the second derivative test, we need to find out the second derivative. But before we can find the second derivative, we're going to find the first derivative. So the first derivative here is negative 3 times 5 times x 5 minus 1 plus 5 times 3 times x 3 minus 1. So we get negative 15 x to the 4th plus 15 x squared. And now we can find out a critical number by setting f prime of x equal to 0. setting a prime of x equals 0, find critical numbers. That means negative 15 x to the fourth plus 15 x squared equal to 0. Factor out negative 15 x squared, then we end up with x squared minus 1 equals 0. And 3 zeros, x squared equals 0, x squared minus 1 equals 0, x equals 0, that's first critical numbers. At 1, we get x squared equals to 1, so x equals plus minus 1. So 2 more critical numbers. So we have 3 critical numbers. The next step, we got to find out the second derivative. F double prime of x equals derivative of first derivative. So we got a negative 15 times 4 times x to the third. Using the power rule, 15 times 2 times x. Then we get negative 60 x cubed plus 30x. After that, we can start doing the testing of interval. Okay. Okay, so let's just get to test all 3 test points. Or critical numbers. I think it's better put it on the critical point. Critical point. First point, let's take a look. When x equals 0, f of 0 equals to 0. So 0, 0, that's the first point we're going to test. Then we determine the sign of f double prime of x. So f double prime of 0 give us actually 0. So in this case, the test fails. Conclusion. Second derivative test fails. The second point, negative 1. When x equals negative 1, now from negative 1 equals to negative 60 times negative 1 to the third plus 30 times negative 1. We have negative 60 minus 30, which is 30. Discrete. Okay. No, hold on. We plug back to the original function to get a point. So f negative 1 equals negative 3 times negative 1 to the 5th plus 5 times negative 1 to the third. So get negative 3 times negative 1 plus 5 times negative 1. So we get 3 minus 5, which is negative 2. So second point is negative 2. So f double prime of negative 1 equals to negative 60 times negative 1 to the third plus 30 times negative 1, which gives us 60 minus 30 greater than 0. So this is, that means we have relative minima according to the theorem, right? Relative minima. Okay, the last one is x equals to 1. For 1 equals to negative 3 times 1 to the 5 plus 5 times 1 to the third. So it's negative 3 plus 5 equals to 2. So it's 1, 2. So f double prime of 1 equals negative 60 times 1 cube It's 30 times 1, which is negative 30, less than 0. Then we know there's a relative maximum here. Alright, so that's pretty much the whole process, and this table actually gives us very good summary result about all those critical points, and identify all those extremes within those critical points. I'm going to take a look at the detailed solutions. What I want you to show you is this is the table we just did, right? Table very clear, where you can see the relative extremes and then when the test fails. And let's take a look at the graph, as you can see right here. Relative minimum occurs at a -1 and -2. And if you look at x00, then that's test fails, which is the concavity. This is actually the point of infraction, because it's concave downward, concave upward. So that's point of infraction. And at 1, 2, then we have a relative maxima. And that exactly matches what our analysis is. Okay, so that's pretty much it.
This class might not be one, isn't it? 6 students. Maybe we can see. Station